Time to tackle the review questions today. All right, so the first review question that we had was to find the area in square yards of a rectangular room that measures 12 feet by 21 feet. Obviously, the tricky part of this is the yards instead of the feet. So you begin, do stop and start. I'll go over it with you. My time, a few seconds. Your time when you're done with the question. Okay, so the area is 12 feet by 24 feet, which is 288 square feet. Now, the next thing to consider, though, is that it doesn't want square feet, it wants square yards. So what am I going to do about that? There are a couple of ways to look at it. One way is to say, well, I'm going from a smaller unit to a bigger unit. Namely, I'm going from feet to yards. So that means I'm going to divide. But what do I divide by? Well, the thing is, the conversion factor is 3, right? Because there's 3 yards in a foot. But you actually have to divide by 9 because the conversion factor, feet to yards, is being squared. So 3 squared is 9. Or you could do 3 and then 3 again. So 288 divided by 9 is 32 square yards. Now, another way to do it is to say, okay, well, I've got 288 square feet. I need to convert to yards. So I'll do 1 yard is 3 feet, 1 yard is 3 feet. And I set that up so that I can eliminate the feet units. Think of it as die, cancel, abducted by aliens, squished by Sasquatch, whatever you want. The bottom line is all of those feet go die. And this way, you are also left with 32, namely 288 divided by 3 and then 3 again, or 9 total, gives you 32 square yards. Now, you could have handled this even another way. You could have said to yourself, well, let me convert them to yards at the very beginning. I could change 12 feet to 4 yards and 24 feet to 8 yards, and then done 4 yards times 8 yards is 32 yards squared. Next up, convert 9 feet to inches. Go ahead. Okay, so feet to inches is big to small, so you're going to multiply. The factor is 12, so 9 times 12 is 108 inches. I do want to mention one thing to you while I just thought about it. You know, when you take your test, obviously, you take the test at home. It's obviously open book. So you want to make sure that you have those conversion factors available to you. I don't list them, like I'm not going to write on a problem 12 inches is in a foot, but I did give you all of those conversion factors on different PowerPoint slides, and you can either print out that slide or you can take a picture of it with your phone or a screenshot of it with your phone, whatever you want to do. But I would have all of those in a file, in an album in my photos called either conversion factors or Math 1111, whatever you want to have it in there, so that during the test you can just take it out and you can look at those conversion factors and know what they are. Okay. The exchange rate as of today, January 8th, well, that's not today, but the day I wrote this, 2021 is $1.14 per euro and 0.88 euros per dollar. Answer those 2 questions. Go ahead. Okay, so how many dollars are 95 euros worth? Well, we have to set this up so that the euros will cancel here. So I want the one that converts the dollars to euros. So that would be $1.14 per euro. The euros are going to cancel out. You're going to multiply 95 times 1.14 and you come up with $108.30. How many euros are $300 worth? Well, I do $300, and this time I do euros per dollar so that the dollars cancel out. And I'm left with 300 times 0.88, which is 264 euros. All right. So the big takeaway to remember here is when you're going to convert to something, like in the first problem, dollars, you want to convert $2, you want to make your euros cancel out. In the second case, you want to convert 2 euros, so you want to make sure your dollars cancel out. Remember, the word per means divide. So per euro means euros in the bottom. Per dollar means dollars in the bottom. Okay, try those 3. Go ahead. Don't forget stop and start. Okay, how many quarts are in 7 gallons? Well, that's big to small in the sense that you're going from gallons to quarts. So you're going to multiply. The factor is 4 because there's 4 quarts in a gallon. 7 times 4 is 28. So the answer to that one would be 28 quarts. How many quarts in 44 pints? Well, now you're going from small to big because pints are smaller than quarts. And it just so happens that means you're going to have to divide, and the factor is 2. So 44 divided by 2 is 22. And then how many pints are in 9.5 gallons? Well, this is a two-stepper. First, you're going to go big to small when you go gallons to quarts. So the factor is 4. Again, gallons to quarts. 9.5 times 4 is 38. Then you have to go from 38 quarts to pints, which is again going from bigger to smaller. A quart is bigger than a pint. So you're going to multiply. Scale factor is 2. So 38 times 2 is 76. And there's your conversions. Now, that's the English system of conversions. And we mentioned this the other day. It's a little awkward for us when we think of metric conversions because we didn't grow up with this stuff. But this is really a whole lot easier because you just slide decimal points around and put some zeros in here to get these right. Try these 3 conversions. Go ahead. Okay, so first, 5.2 hectometers, 2 centimeters. Remember, King Hector died drinking deadly cough medicine. So here's my hecto column, and the decimal point always goes to the right side, theoretically, so that's 5.2. And then I fill out zeros until I get to the centi column. And that's my answer, because now that decimal has moved, it always goes to the right of the column. It's now moved to the right of the centi column. It went from the hecto column to the centi column. So that's 52,000. Convert 3 centimeters to decameters. So I start with the 3 in the centi column, decimal on the right, and I move that until I go to the right of the deca column, and that makes 0.003 decameters. Last, 4.7 centimeters to kilometers. So I have to put that decimal to 4.7 so that the point is on the right side of the centi column. And then I just keep filling it in backwards and moving the decimal until I get it on the right-hand side of the kilo column. That gives me 4 zeros, 47.000047. So that's how I apply metric conversions. And again, I personally, if I were you, I would have a picture of this in that album with conversions for when I take my test. All right. 2 more to do before we get to the new material for today. Absolute and relative change. A diversified portfolio grows from 1800 to 2250. Keep in mind, the reference value is always the one you start with. Like if you go from New York to Los Angeles, you began in New York, so that would go first. If you went to New York from Los Angeles, then Los Angeles would go first because that's where you're going from. So go ahead, figure out the absolute and the relative change. Okay, so absolute just means do the calculation. This is really easy. And yes, there are absolute questions on your test coming up. There might be 2 of them on the whole test. There's at least 1. I think there's 2. The absolute change is the new value minus the reference value. The new value minus the reference value. So that's 2250 minus 1800. Which is $450. Now the percent change is the absolute change over the reference value. In other words, whatever you started with, which in this case was 1800. So I do 450 divided by 1800 and I get a 25% relative change. Relative changes are always going to be in percents. Okay, next, solving percentage problems. You purchased a shirt with a labeled pre-tax price of $71. Local sales tax rate is 7%. What is your final cost? Go ahead. Okay, so the final cost is the labeled price plus 7% of the labeled price. So the labeled price is 100%, and the 7% more because of the sales tax means you have to do 100% plus 7%. Kind of like factoring in the distributed property if you look at it. So that's 107% of or times the labeled price. So 107% percent, which is 1.07 times 71, is 75.97. Now, that's not the only way to do it. You could have also just figured out what 7% of the price of $71 is, done that calculation. I think you would have come up with 497, and then done 71 plus 497. Either way, they both work great. This technique is a little slicker, and it's a little bit less complicated because the addition is a really simple addition. It's not that the other one's overly hard, and you do have a calculator, but it's a little bit easier to do in your head. All right, so those are the review type of questions. And yes, somewhere on your test, it will be necessary to do one of these where you think of the 107% as the 100% plus the 7%. Okay, time to get going on classwork contemplations.